Okay, so we're doing the beginning of Learning Target 7. Learning Target 7 is actually in 2 pieces. All right? Learning Target 7 talks about finding characteristics of the equation in standard form and also in general form. We'll do general form tomorrow. But we're going to do standard form today. All right, so it all kind of goes together. We have 2 different forms, though. So we're going to focus on one today, one tomorrow. You should have plenty of time to do your homework. So for each of these, it says, for the equation of each ellipse, find the coordinates of the center, the foci, and the vertices. That's all on that note sheet. You're going to have to get used to not using that note sheet, though, because on the red sheet, not all that stuff is given. So you got to make sure you know what you're talking about. On all of these, the first thing you should do is identify whether it's horizontal or vertical. How do I do that? Looking at an equation. You find the bigger denominator. So in the first example, which one has the bigger denominator? The x. So that makes this horizontal or vertical? Horizontal, because it's under the x. Right. So then on the second example, it's also under the x, so it's also horizontal. If the larger denominator was under the y, it would be vertical. That should make a difference because there's 2 pieces to that note sheet, that chart I gave you yesterday. You got to make sure you're using the right piece, the horizontal piece or the vertical piece. Okay? All right. The larger denominator is also always a squared. So for the first example, which number is a squared? 36, which makes 4b squared. Right? On the second equation, 81 is a squared and 49 is b squared. If just for argument's sake, because that way everyone kind of knows what we're talking about. If these had been switched, right, then it would be vertical, and this would be a squared still, and that would be b squared. The larger number is always a squared. Okay. Anyway. All right, let's find the center first because that's easy. What is the center for the first example? 0, 0, right? Because you should have x minus h squared plus y minus k squared. So what's the center for the second example? 0, 4. Right, that should not be difficult to figure out.
I thought it's HK and it flipped.
You have y minus k squared, so k has to be 4. If it said y plus 4 squared, then k would be negative 4.
Yeah.
Okay. Okay. All right, let's find the foci then. This is what's on the red sheet. So these are both horizontal to the same thing. So you look at your red sheet, you look at your note sheet, whichever one you're going to look at, whichever. And it says that for a horizontal ellipse, you have h plus or minus c comma k. That's supposed to be a c. Well, I know h and I know k. It's not a problem. I also could figure out a and b if I needed them, but I don't have c. So also on the red sheet, it says c squared equals a squared minus b squared. So c squared equals 36 minus 4. C squared then should equal 32. So c will equal the square root of 32. That's 16 times 2. So that could also be 4 square root of 2. You can leave it to whatever you want. I don't care. You will always have c squared equals a positive number because a squared is always bigger than b squared, so You should always have a positive difference. Uh-huh. All right, so I'm going to write that out for my foci. I have 0 plus or minus 4 square root of 2, comma 0. Well, that's just plus or minus 4 square root of 2, comma 0. If h wasn't 0, and it was 7 or whatever, you would just leave it that way, 7 plus or minus 4 square root of 2. You want an exact answer, so I don't want a decimal. Everyone with me, though? Okay, here's the trick so that you don't have to memorize a bunch of stuff and you aren't freaking out on quizzes. You can list them separately if you want. That's fine. Here's how you should use the red formula sheet to your advantage. I've determined the foci. That equation is on here. For the major and minor axis vertices, those are not on here. But the major axis always includes A, right? A is the semi-major axis. A was always on the long part of the ellipse. All right? So, since the foci have H plus or minus C comma K, the major axis vertices are always going to have H plus or minus A comma K. It's the exact same thing with an A instead of a C. All right? Because that's not on your red sheet. But the foci formula, or what I call it a formula, is. So you just need to know you just interchange those letters. It's not like something else you have to memorize. We should know what A is. What is A? A is 6. A squared is 36, so A is 6. So I have 0 plus or minus 6, comma 0. So it's 2 different points. For the minor axis vertices, also not on the red formula sheet. But since you added something to H for the major axis vertices, the minor ones then you add to the other coordinates. So we add it to K. And you add B, because minor axis includes B. Everyone understand my rationalization there about not having to memorize a bunch of stuff. You just kind of use what that foci formula to find those other two. HK is your center, so you already have that. So we have what's B? 2. So you have 0 plus or minus 2. Now, if K was 7, in this case, I could find the 2 points, right? If K was 7, I would have 7 plus 2, which is 9, and 7 minus 2, which is 5. You can actually figure those numbers out. You should probably do that. In this case, it was easy, and it was zeros. Everyone understand where those came from? Yes? Good? So we found the center, the foci, and the vertices, and so it says then graph the equation. So our center is at 0, 0. You don't have to graph the foci because they're not actually on the ellipse. If you want to include them, you can, but they're not actually on the ellipse. I've got the major axis vertices at positive 6, 0 and negative 6, 0. So that's 6, 0 and negative 6, 0. And the minor axis vertices are at 0, 2 and 0, negative 2. Then you do the best you can at drawing an ellipse. I mean, that wasn't awful. Could be better. Does that make sense? Do I need to do the other one?
So if it was vertical, your minor and major are totally different, right?
It's opposite. Yes. So let's actually, I'm going to make the next one vertical. We're going to switch the denominator so you have something different. Okay? Does that make sense? We're not doing the same exact thing over again? Can I erase all this?
So it's not going to be horizontal anymore.
Yeah, we're going to make it vertical so that we do something different. So I'm just going to switch the denominators like we were pretending earlier anyway.
So 49 goes under the X.
It's part of the equation. You need to go back and look at those definitions. A is a semi-major axis. It's from the center to a vertex on the major axis. It's a distance. You can count on Learning Target 6. Okay, so making this vertical. So A squared is 81 and B squared is 49. We still have the same center. I erased it, I didn't mean to. The center is still 0, 4. That does not change. What you have to be careful of is when they write an equation and put the y part first, that you make sure that that's still k and put it second in the center. All right, so we're going to go through that same process again. We have the center, so we need to find the foci. That equation is on the red sheet. So for the foci, for a vertical ellipse, you should have h, comma, k plus or minus c, which is the opposite of what we had last time. Last time we added and subtracted c to h. Now it's at k because it's vertical. Right. And again, that's on the red formula sheet. You can memorize this part. That one, foci is. And again, I'll talk you through that again with the major and minor about how you don't have to make it just memorize. You can work with this foci equation or formula, whatever you want to call it, to figure it out. All right, so we know h is 0, we know k is 4, but I don't know c. So we find the c the same way. So c squared equals a squared minus b squared. So we have 81 minus 49. Was that 32 again? So we have the same exact thing? You kidding me? Or you can leave it as a square root of 32. Whatever you want to do. So for the foci, you have 0, 4 plus or minus 4 square root of 2. And you can leave it that way. You can separate them if you want to. Right. Everyone good so far? Questions so far? All right, for the major axis vertices, again, you don't have this on the formula sheet, so you need to use this foci equation to your advantage. For the major axis vertices, the foci are on the major axis. So h or k, whichever one you added and subtracted c to, is what you add and subtract a to. So we should have h, comma, k plus or minus a. It's always a for the major axis. So what is a? A is 9. So I have 0, and I have 4 plus or minus 9. So this will be a time I'd want to split them up and then actually want to do some math. So you get 0, comma, 13. And 0, 4 minus 9 is what, negative 5? Everyone knows where those came from. Everyone good with that? Then the minor axis, again, whatever you just added to, h or k, you do the opposite for the minor axis, and you add and subtract b. Since we were just adding and subtracting to a, we're going to add and subtract to h. So what is B? 7. So we have 0 plus or minus 7, comma 4. So my 2 points are 7, 4, and negative 7, 4. So then we just graph the major and minor vertices and we can draw our ellipse. Our center was at 0, 4. Our major axis vertices are at 0, 13, which this is 10, so 11, 12, 13 is up there. And 0, negative 5. And then 7, 4, negative 7, 4.
Are you getting the 0, 4 from
Yeah, the 0, 4 was the center. And then you do the best you can to draw an ellipse. That's really bad. Everyone know where all those numbers are coming from. The more you work with them, I think the better you're going to get at, okay, where do I add, subtract A or add, subtract B, that kind of thing. I would suggest, since I gave you the pre-calculus formula sheet the other day, your own version, right? I would suggest you try to do your homework with that, where you don't have the major and minor axis stuff written out for you.
one side of it is
It's on both sides. But so that way you're practicing, and that way the day of the quiz, you're not trying to figure it out. So don't use that chart I gave you yesterday as a crutch when you can't use all of it on the actual quiz.
yeah, but it's in private. I don't know.